guys, welcome back to this channel. Nice to see everyone again. And we are coming to the last video of your topic 7, where we will cover the chemical property of carboxylic acid. And in this video, we are going to cover 4 different chemical reactions of carboxylic acid. The first one is the reaction of carboxylic acid with your group 1 metal. The second is your reaction of carboxylic acid with your group 2 metal. So the group 1 metal, for example, you have your sodium, you have your potassium. Your group 2 metal, normally, that we will use is your magnesium, your calcium, or your barium. So that is your group 1 and group 2 metal that we will look into. The third reaction is the esterification of your carboxylic acid and also alcohol, formation of ester. Last but not least, we'll look into the neutralization with the base, where in this base, we will react with 3 different bases, which is your NaOH, your NaHCO3, and last but not least is your Na2CO3. We are going to look at the differences between the reaction of your carboxylic acid with the 3 different bases. So let's jump straight into the reaction of carboxylic acid with the group 1 metal. So the group 1 metal that I have over here is sodium and also potassium. And obviously, we are going to focus on your carboxylic acid group because that is the group that will react with your sodium. And in this group, who will actually react with sodium is actually your OH group over here. What is the changes that happen to OH? Is the hydrogen. Alright? The hydrogen over here will be removed and replaced by the Na. So when I remove the H over here, the H will then become H positive. The O will actually become O minus. The Na, we know that is a group 1 metal that will always become Na positive. So Na positive will replace the H that removed from the OH. So make sure you only focus on the OH in your carboxylic acid, where we will remove the hydrogen only. The O will remain there. And the rest of the thing that doesn't change shall remain unchanged. The R group will be there. The carbon double bond O shall remain unchanged. The O will be there. So what is changing? The Na will replace the H. The hydrogen will then remove as a hydrogen gas. Alright, so that is the reaction of your carboxylic acid with the group 1 metal. Let's see what happened when I react with my potassium. It will be exactly the same because your potassium then will become K positive. Again, we will focus only on your carboxyl group, and in specific, we will actually focus on the OH. In more specific, we will actually focus on the hydrogen on the OH. And the hydrogen over here will be removed, replaced by the K plus. And the things that doesn't change shall again remain unchanged. But you have another way of writing. You can write it in the form of charge. So you can write it in the form of O minus, K positive, like this. Okay, the byproduct will still remain your hydrogen gas that you remove from the OH. Just a kind reminder, if you are not having charge for the O and the Na, both shall have no charge, alright? Just O and Na. But if you are having charge, for example, like this, you are having your O minus, then your group 1 metal also must have the charge. If you decided to not putting in the charge, then both positive and negative no need to write. But if you decided to put in the charge, then the both negative and positive must be there to balance off each other. The byproduct must be there if the question asking for chemical equation. And that is the reaction of your group 1 metal with your carboxylic acid. Only focus towards the OH group. And in more specific, we only focus on the hydrogen. Okay? Simple. Let's try an example of this. So what happened when the question gives you in the form of condensed? Simple, expand the content. You can expand the entire group, or to make your life easier, you just expand the COOH. The rest of the group shall remain the same, just copy it back. The carbon that holding the OOH is actually your C double bond O OH. Reacting with your group 1 metal, so I can react, let's say, with my sodium. We know that your sodium is your group 1 metal. So what will happen, guys? What will change? Where is the changes? We will focus only on the carbon that holding the COOH. And to be more exact, we will focus on the OH. And we know that the H that attached to the OH will be removed and replaced by who? It will be replaced by the Na. So, the rest of the R group over here, the rest of the R group that doesn't change at the back, shall remain unchanged. Just copy the entire R group back. Make sure the bond is bonded to the correct carbon. The attachment must be correct. The carbon that holding the double bond O shall still be there, and the OH will then replaced by the ONA. And the byproduct that you will produce is your half hydrogen gas. And that is the complete chemical equation when you have your carboxylic acid react with your group 1 metal over here. Simple, alright? So we only focus on the hydrogen that attached to the OH. Next, let's look at the reaction of your carboxylic acid with your group 2 metal. So the example of group 2 metal that we have is your magnesium and barium over here. It will be very similar as the group 1. We will focus only on your carboxyl group. To be more exact, we will focus on the OH. And to be more specific, we will actually focus on the hydrogen that attached to the O. And what happened is the hydrogen will be removed. But we know that over here, your hydrogen only H+. Your O, after the hydrogen leave, will then be O-. Since it's a group 2 metal, your magnesium will actually become Mg 2+. So, I have a positive 2, but I only remove a positive 1. How many O- do I need? I will need 2 O- to balance off with the 2 positive, right? That's why the product that you will form over here will be your R. C double bond O will remain unchanged. Your O need 2 of it. You need 2 of this O to bond it with 1 Mg. And the byproduct that you form will no longer be half hydrogen gas. The byproduct that you form will be hydrogen gas. The byproduct will be a hydrogen gas full, not a half hydrogen gas, because we are going to remove 2 hydrogen, alright, from 2 different carboxylic acid combined with 1 Mg2+, due to the presence of 2 positive and the oxygen is only O-. So O- and 2 positive, so you need to have 2 O-, alright, to react with 1 Mg2+. Therefore, you must have your COO in the bracket of 2 combined with 1 Mg. Okay? And like what we have learned previously, if you are not putting in any charge of the O, the magnesium also have no charge. Alright? Neutral. Both must be neutral. The same thing when you react with your barium, knowing that your barium is also your group 2 metal become Ba2+. We will still focus on the carbon that holding COOH. Focus more specific on the OH. Even more specific is the hydrogen. So what will happen is the hydrogen will be removed, knowing that your hydrogen is only a H+, and your O can only become O-, but your Ba is a Ba2+. So to balance off, you need 2 of COO-. And as always, the thing that doesn't change shall remain unchanged. And for this answer, I decided to put in the charge. So you have your O- over here. Put down the bracket, you need 2 of this carboxylic acid 2 combined with 1 Ba2+, forming a byproduct of hydrogen gas. And check it out, guys. If you decided put in the charge for the O-, therefore you must also put in the charge for Ba2+. Okay? Both are correct. So up to you whether you want to write the charge or not writing the charge. Alright, simple. Let's try an example of carboxylic acid react with your group 2 metal. So this is my question. This is my carboxylic acid that will react with my group 2 metal. As always, when the question gives you condensed, what do? We are going to redraw it and expand the group that we want to look at. So when I'm going to expand it, the ring shall remain unchanged because we know that we are not going to use the ring. We only expand the C double bond O, OH. And let's say my group 2 metal that I'm going to react with right now is my Ba2+. Okay? And when I react with my group 2 metal, knowing that the changes that we only focus at is your carboxyl carbon, and also in more specific, the hydrogen that holding the O. And we know that this hydrogen will be removed. So the rest of the group shall remain unchanged. Just copy it back, it won't change. The C double bond O also remain unchanged. But what is the changes? The O over here, we need 2 of this group. Because Ba is a group 2 metal holding 2 positive. So Ba1 but COO2. Okay? And your byproduct over here is your hydrogen gas. And that is your complete chemical equation when your carboxylic acid react with your group 2 metal. Okay? Simple. Easy. Very easy. If you realize, it's actually very similar as what you have learned in your alcohol. But in the alcohol, we focus on the OH. In here, we focus on the COOH. Okay? But the changes still happen to the same hydrogen. The hydrogen that attached to the OH. Alright? Let's move to the third chemical reaction of carboxylic acid, which is esterification. Same thing, guys. We have come across esterification in your alcohol. So what is the things that we are going to use to form your ester? We are definitely using your COOH over here. We are reacting with alcohol. With the presence of acid, you will then form your ester. Okay? So let's see what happened. Focus on the COOH. Focus on the carbon that holding the OH. And what will happen? In your COOH, we will remove OH. In your alcohol, we will remove the hydrogen that attached to the OH. So this is the group that we remove. This is the group that we remove. Okay? And this is the carbon that loses the OH. And this is the oxygen that loses the H. So the new bond will be formed between this carbon and this oxygen. The rest of the group that doesn't change shall remain unchanged. Let's copy the group, starting off with the R in your carboxylic acid. This R, bonded to the carbon, alright, holding double bond O. So this is the carbon that loses the OH. So this carbon will be forming a new bond with this oxygen. So this oxygen will be sitting over here. The oxygen that is bonded to the carbon and the rest of the group, you basically just copy. So the carbon that holding 3R group will be then just sitting right next to it as what you have attached. Okay? And this is the ester that you form. Knowing that your ester must be a carbon that holding C double bond O, holding C single bond OC. That is your carboalkoxy group. And that is the ester that you produce. Okay? So always remember, in your carboxylic acid, you will remove OH. Okay? In your alcohol, you will remove H. So you will form a new bond between the carbon that loses the OH and also the oxygen that loses the H. So what do you think the byproduct will be? The byproduct will be definitely your H2O because you remove your OH and also your H. So the formation of ester, the byproduct will be H2O. Simple, easy. So let's look at an example over here. I have my carboxylic acid. I have my OH. So make sure you expand this for a bit. So knowing that your COOH is actually your C double bond O single bond OH. Okay? And you know that in your esterification process, you need to have the presence of your acid. And also we are going to remove water. So in your esterification, we are going to remove water and your carboxylic acid is the one that will remove OH. While your alcohol will be the one that remove H. So the new bond will be formed between the carbon that loses the OH and also the oxygen that loses the H in the alcohol. The rest of the group shall remain unchanged over here. So your carboxylic acid will still be holding the 6 carbon ring at the back. The carbon that holding the double bond O will still be there. Knowing that this is the carbon that loses the OH. So it will form a new bond with the oxygen that loses the hydrogen just now. And this oxygen that loses the hydrogen bonded to this R group. Make sure the bond is correctly. Next to the oxygen is the CH2. Recopy the whole thing. The CH2 bonded to the CH. The CH bonded to CH3 and also CH3. So this is from the alcohol and this part is from your carboxylic acid. Obviously, your byproduct is your H2O that you remove from your carboxylic acid and also alcohol. Alright? That is the formation of ester. And it's exactly the same as what you have learned in your alcohol. Always remember, carboxylic acid is the one that will remove OH. Your alcohol is the one that will remove H. And the new bond will be between the carbon that loses the OH and also the oxygen that loses the H. That is where the new bond being formed. Simple, easy. Last but not least is the neutralization of your carboxylic acid with base. But we have 3 base over here if you look at it. I have my NaOH, which is your sodium hydroxide. The second base is your NaHCO3, which is your sodium bicarbonate. Last but not least, you have your Na2CO3, and this is actually your sodium carbonate. So we are going to react with 3 different bases, your sodium hydroxide, your sodium bicarbonate, and also your sodium carbonate. But the product will be very similar because we will all focus on the COOH group. And to be more specific, we don't really focus on the COOH to be honest. We actually focus on the hydrogen that's sitting with the OH. This is the person that we will focus. And you know what is the changes? Similar as what you have learned in the reaction with group 1 metal. We're actually looking at the changes between hydrogen and sodium. Okay? And as you know, sodium is your group 1 Na positive. Hydrogen will be removed, which is your H plus. So you replace the H with the sodium. And that's it. So your product is as simple as the R and the C double bond O remain unchanged, but the changes happen to the OH. The OH right now will become ONA. The byproduct that you produce is your H2O. Why H2O? Because you have the H that you remove and also the OH that you have in your sodium hydroxide. So the H combined with the OH, that's why you have your H2O as your byproduct. While when you react with your sodium bicarbonate, what will happen? Same thing. The product will be exactly the same. C double bond O, the OH will also change to ONA. And the only things that different, guys, is the byproduct. You will still be having your H2O, but at the same time, you have your carbon dioxide gas due to the presence of the CO3, your carbonate. So the only changes is the presence of CO2 gas when you react with sodium bicarbonate. And when you react with your sodium carbonate, again, the product will also be the same. The changes will still happen to your OH, replaced by ONA. And the byproduct will be the same as you react with your sodium bicarbonate, where your byproduct will still be your H2O, CO2. Again, due to the presence of CO3. That's why you produce carbon dioxide gas. So look at the product. All the product right now is the same, where you are changing your OH to become ONA. That's it. Even though you are using different base, the effect of different base is only on your byproduct. When you're only using sodium hydroxide, the byproduct is H2O. But if you are using sodium bicarbonate and sodium carbonate, your byproduct will be H2O and CO2. Okay? So that are the differences when you're using different base to undergo neutralization with your carboxylic acid. So I have a carboxylic acid over here. And if I react this carboxylic acid with all the different bases, it will just be the same. So let's say I'm using this carboxylic acid given to react with all the 3 different bases. So like expand this structure for a bit. So the structure is your CH2. And this CH2 holding a COOH. So the COOH is actually your double bond O, single bond OH. Knowing that the reaction only changes to actually the hydrogen will be removed when you react with the bases. And we have 3 different bases that we are going to react with. The first one is your sodium hydroxide, NaOH. Second, you can react with your sodium bicarbonate, so you have your NaHCO3. Last but not least, you can react with your sodium carbonate, which is your Na2CO3. And everybody knows that the hydrogen will actually replaced by the Na in all your bases. So the OH will then become ONA. So all your product shall be the same because all your product is actually simply changing the OH to become ONA. So the C double bond O remain unchanged. You have your ONA. And since your base over here is your sodium hydroxide, therefore your byproduct will only be H2O. And over here, when you have your sodium bicarbonate, the product will still be the same, where the CH2 remain unchanged, the C double bond O also remain unchanged, the OH substituted by O and A. And the only difference is your byproduct. Your byproduct will be your H2O and also CO2 gas due to the presence of carbonate. The same thing happens when you have your sodium carbonate. The product will also be the same. No changes on the product. You can see that already by right. Where the double bond O remain, the OH will then become ONA once again. And the byproduct for this case will be the same as your sodium bicarbonate, where you will have your H2O and also CO2 as your byproduct. Okay? So the main changes other than forming your ONA over here as your product, I think the focus will be on the byproduct. If you are using a normal sodium hydroxide, the byproduct will be water. If you are using a sodium bicarbonate or if you are using a sodium carbonate, the byproduct will be H2O-CO2, H2O-CO2. Simple, easy. And this is the last chemical reaction of your carboxylic acid. And I think that's it for this video. If you have any question regarding chemical reaction of carboxylic acid, drop the question at the comment below and I'll get back to you as soon as I can. Alright? And don't forget to like the video and subscribe to my channel. I'll see you again in the next video and thank you for watching.